sign, all of these symbols are technically called operators. I'll write this down here. Now, the operator performs, in the case of a binary operator, it performs on two operands. That's what your values are. And these two words are kind of close to each other, but it's good to differentiate the two because Derek over here loves using big words all the time. And you won't know what he's talking about unless you know the terminology. So operator refers to the actual symbol, and operand refers to the values that you're computing on. Just so you know. Now these specific operators, 1, 2, 3, 4, 5, 6, there's 6 operators. These are called binary operators. And don't get that confused with binary as in 1, 0, 0, 0, 1, 1, all that stuff. Binary means 2 in this case, which means that this operator always, always, always takes 2 operands. Now, to contrast that, we have binary operators. We also can have unary operators and ternary. And technically, there's only one ternary operator, and it's confusing as crap, and no one ever uses it. But the urinary ones, they're used every so often. The urinary ones. What are the urinary ones?
Like if A equals 1, and then we see if it is true or not.
No, because 1 is still technically considered an operand. A urinary operator would be similar to, Richard,
What?
the plus plus, the minus minus, because they perform an action on only one operand. So, not A would technically be a urinary operator. So would the 1's complement tilde sign, the urinary negation, the urinary plus, the typecast. Huh? I didn't know that. Address of. Well, we'll stick to binary for now because it's the most common one. Let's start doing some math. Fun time.
With
So,
Daniel.
Hmm?
With Dan.
We have these two numbers. Is this all good? Have you written this all down?
I got a video of it.
But this all makes sense. Binary operator means that it takes 2 operands, right? Make sense? Urinary operator means it takes 1 operand, and ternary operator means it takes 3 operands.
Someone get at the door?
In case you've already forgotten, Derek, the ternary operator is the conditional operator. It's the, don't worry about the Schweitzer, it's the question mark colon one. And you pretty much, you take a Boolean condition, B is greater than A, you test it, and you say if it's true, let A equal to 5, but if it's false, let A equal to 6. It's a confusing operator, but 3 operands, yes. There's the 1, 2, 3. But no one uses it because we have if statements. And the urinary operates on 1. We'll stick to math though right now, binary operators. So all makes sense. I'm going to erase it all.
Mention the if statement. If statement.
We'll get to it. It's all conceptual right now.
Well, I think you did.
So math. Let's say up here I say byte x equal to, pick a number,
23.
23.
What's farther than 23? 24.
Byte y is equal to
24.
24. Okay. And we'll make another variable. We'll call it, byte, and we're not going to initialize it yet.
25.
And remember, we can do that. We can split up the declaration and initialization.
That's called the.
Initialization and the
So the byte is equal to that's and afterward byte. What was it called afterwards again?
byte x is 23, byte y is 24. This is byte ANS. ANS stands for
ANS. Okay.
This is just what I chose to be the name of my variable.
All right.
And we did not assign it a value yet. So let's do that. Let's say ANS is equal to x plus y semicolon.
X plus y.
What's ANS?
X plus y.
Right? 47. So ANS is 47.
Oh, 47. Oh, I didn't see that. Yeah.
What if I said, let's not worry about negatives right now. Let's say y minus x. It's very simple. 24 minus 23, right? It's 1. So I'm just showing you what the actual binary arithmetic operators are. Binary arithmetic operators. Get the plus sign. It takes 2 operands, right? That's why it's binary. Get the minus sign. It subtracts. We have the multiplication sign. Actually, it's not an x. It's an asterisk. So what's 23 times 24, Derek? I'm not going to do that in my head. I'm lazy. 552. That's what the value of answer would be. And then we have the division. Take note of what kind of a slash it is. It is a forward slash. Wait, no, did I do that one wrong? No, I'm right. So, this brings up an interesting note. What's 24 divided by 23, Derek?
1.04.
1.04. So what's the value of ANS, Webster?
1.04. Wait, ands? Yeah.
Are you sure?
It's y divided by x.
Y divided by x is
That frickin' huge number.
1.04, right?
Mhm.
But let's say there were a magical print function that we don't know about yet, but let's say I said print ANS. What number would you actually see? 1.04?
Yeah.
You sure?
For
what
what?
data type are we using?
Byte?
A byte?
0 ones, basically?
No, it's an 8-bit number. However, do bytes support decimals?
No.
No. So I can't actually store that 1.04 inside of this variable because it's a byte. What I would need to do is make this a float. That way when I print it, it would say 1.04. Now let's say we didn't do that though. Let's say this was a byte. It wouldn't actually give us an error. What it would do is chop off the end of it and say the value of answer is 1. So keep that in mind.
Does it always round down?
Yes, I believe so. And you can actually, there's math operating. Never mind, don't worry about it. So there are your 4 basic binary math operators. Wait, no, we're forgetting one, aren't we? Modulus. The glorious modulus. This one is going to be new to you. Is it like this? Or the other way? I was right the first time, right? Okay, modulus. It's a percent sign. So, what is y modulus of x? What modulus actually does, well, let's use simpler numbers. Let's make this 5. It's a 5. This is a 2. What modulus actually does is it takes your 5 and it divides it by the 2. And the answer to this would be 2.5. But instead of storing 2 in the variable, it's actually going to store what the remainder is in the variable. So answer is going to be equal to, if I were to print it, and if this were a float, and we printed ands, answer would actually be equal to a half, 0.5. Because that's what the remainder of our division was. Is that right, Derek? that's fine.
I thought like if, like 2 went into 10 or 11,
Or would the remainder be 1?
I thought it would give you a 2. And not give you a remainder.
5 modulus 2. It goes in 2 times
But it doesn't.
with a remainder of 1 actually, because it can go in 1 time, but it can't go in another time. So it can go in 2, then it can go in 4, but there's actually another
Mod 5 on
5 mod 2, yeah. Break out the C compiler there.
1.
Point 1? Is that actually a function on there? Wait a minute. Let's consult the big daddy of it all. Did I not?
Oh, fuck you.
Almost typed in my
2 days.
password there.
Really, 2 days. Ah. Basically, I cracked the top.
That would sound like a difficult sentence to say.
Can't do it. Is that going to be fast or no? I hope it's fast.
Doesn't
I
feel
hate
it.
it. I'm gonna try these things. If you know what I mean, Derek.
No idea.
So if you want to watch this, I'm about to type a real you can see just how stupid we actually are. The phone's ringing, Derek. Okay. Let's just go. Okay. Most of this stuff you're actually not going to recognize.
Oh, it's up there.
Yeah, and the color scheme is horrible.
Oh, you're down there now.
Color scheme. Why are you recording me? This is gonna take a while. Oh, there we go. That's better. Am I in insert mode? Yeah, here we go. It's kind of better. It's a little better.
Hold on, let me link to the computer.
Let's say int. Let's just do what we did up there, right? Oh, but this is real C. Crap. Okay, we'll just do ints. Int x equals 2. Int y is equal to 5. And ands is going to equal to y modulus x. And we're going to say printf. And don't worry about the syntax of this.
Hey, how long are you saying here?
A little while longer. The answer is, and then we'll print out what the actual answer is, which is a decimal number, so we'll use %d, and we'll end that with the. What is this?
C.
The answer is, oh, Derek. Sorry. What is this?
C. That's what I had to learn.
Insert a new line. So the answer actually is, if I were to recompile that, no. The answer is 1.
Oh, that makes sense.
So the remainder is 1. So arithmetically, if I were to divide 2 into 5, 2 goes in 2 times into the 5. But if you look at what the remainder is, there's actually one additional number it would need. So if this were a 6, then it would go in. So the remainder is 5 pretty much. It's not a very commonly used, the remainder is 1. It's not a very commonly used operator. However, people do use it when they're trying to determine whether or not a number is even. So let's say I have byte
I know.
20, and I have, okay, yeah, byte 20. We're not going to worry about this variable, or this, or any business. Byte x is 20, right?
Right.
And I wanted to decide whether or not this number is even or not. I don't know if it's even or not, stupid. However, I can figure that out using the modulus. So,
See you guys, it's robotics.
int answer is equal to x modulus 2. Print answer. Okay. So what we did here is we took 20, we'll do that. That looks good. Okay, so what we did here, right, is we said x is 20, and we divided 20 into 2. And we did actually modulus division, so we figured out what the remainder was. Now, what happens when you divide 20 into 2? The answer is 10, right?
Mm-hmm.
What's the remainder?
None.
None.
0.
It's 0. So what would and's be?
10.
No?
0.
It's 0, right?
Right.
Because the remainder is 0. And then down here I said, if the answer is equal to 0,
That's true?
that means the number is even. It's